So welcome all. Today we are going to see something about IP service management. So here actually we will see several other services. Basically they are integrated service and differentiated service. So here we will actually see those two models that we have discussed actually to provide this integrated service. Means here we are going to discuss they are integrated service and differentiated service. Both these models actually emphasize the use of quality of service at the network layer, which is basically we are using IP protocol. So now actually we have IP version 6 where there is a special format to show that this is a flow. We have a flow level there, but in IP version 4 we didn't have that flow level kind of thing. So we needed more services for that. But still, whether it is IP version 6 or 4, we need to reserve some resources. We need to reserve resources on the routers, on the path, so that these flow of data can be assigned a quality of service, right? So basically we have these two models, which is integrated service and another is differentiated service. So let us start with integrated service. So you already know that IP was originally designed for best effort delivery. This means that every user receives the same level of service. This type of delivery does not guarantee the minimum of a service such as bandwidth to applications such as real-time audio or video. Integrated services here, we also call it INTSERV. Okay, so this is a flow-based quality of service model, which means that a user needs to create a flow, a kind of virtual circuit from the source to the destination, and inform all the routers in between to reserve some resources for it. Okay, so basically integrated service is a flow based quality service model designed for IP. So now here we are going to discuss something about signaling, flow specification, admission, service classes, RSVP protocol actually, and problems with integrated services. So basically here we are trying to understand how actually a virtual circuit will be made and this RSVP protocol will be used. So very simple protocol. There are these messages will be sent and the resources will be reserved. That is the only thing we have to see these things, but it is integrated service. RSVP protocol is not that it will be used only in integrated service. It is independent actually. It can be used in other services also. But still, we are reading here integrated service. Let us see what is in these services. Before seeing RSVP, let me tell you about signaling. What can this signaling be? And so basically we know that IP is a connectionless datagram packet switching protocol, right? So how can we implement a flow based model over this connectionless protocol? So the solution is signaling protocol, which runs over this IP and provides the signaling mechanism for making a reservation. Okay, so the protocol is this thing, resource reservation protocol. We call it RSVP. So then let me tell you about flow specification, where we have to understand when a source makes a reservation, it needs to define a flow specification. A flow specification actually has two parts. One is this resource specification and traffic specification. So in resource specification, basically it defines the source that actually the flow needs to reserve, like suppose buffer, bandwidth, etc. And this traffic specification actually defines the characteristic of flow. So these specifications they have to define. Now talking about admission, what happens actually after the router receives the flow specification, these are the things that this particular quality of service requirement is there, right? So these are the things: buffer, this much bandwidth, this much traffic related information. These are the things are requirements. So the router then decides that whether it can admit this service or it can deny this service. Okay, this decision will be based on these two things. One is the previous commitments of the router, that router has already committed to other paths, other services, other flow services, and what it has something currently available resources with it. Okay, after that let us see about service classes. That there can be two actually types of service classes. One is guaranteed service class and another is controlled load service class. In guaranteed service class, actually this type of service is designed for real-time traffic. Real-time traffic. So that real-time traffic which needs a guaranteed minimum end-to-end delay. Okay, so the end-to-end delay, actually you can understand it is a sum of the delays in the routers. At one router we have some delay, another router some delay. So end-to-end, whatever the sum of delays is there, that is the end-to-end delay, and we want to minimize it. So guaranteed, there is a minimum threshold that we cannot have more than this minimum delay. So this was about guaranteed service class. In controlled load, actually this type of service is designed for applications that can accept some delays, but are sensitive to maybe an overloaded network, and we cannot lose the packets. So it is sensitive to losing the packets. So maybe like if at all it is email or other something like this, file transfer. So we cannot lose the packets, however we can accept some delay, no problem. So now we are ready to see our RSVP protocol. So basically in RSVP protocol, what happens is here we are going through this integrated service model. So in integrated service model, actually an application program needs resource reservation, right? So as we have seen this int serve model, the resource reservation is for a flow, right? So if we want to use this integrated service at this IP level, we need to create a flow, kind of virtual circuit network, okay, out of the IP which is actually originally designed for a datagram packet switch network, right? So this virtual circuit network needs a signaling system to set up the virtual circuit before data traffic can be started, right? So the resource reservation protocol, RSVP, is a signaling protocol to help this IP to create a flow and consequently make a resource reservation. Okay, so what RSVP does is actually RSVP can be actually RSVP signaling, it is basically a signaling system, right? So it is designed for multicasting packet transmission, right? It can be used as unicasting, but you can understand unicasting is a special case of multicasting. So this enables this RSVP protocol to provide resource reservation for all kinds of traffic, including multimedia, which multimedia we know that it often uses multicasting. So for that this RSVP supports multicasting this thing. Now receiver based reservation in RSVP, actually the receiver, not the sender, the receiver makes the reservation. So what happens in this strategy, actually we have different other multicasting protocols. So this is similar to this multicasting protocol where receivers are reserving the resources, so no problem, right? Now we have certain messages related to RSVP. Two types of messages, one is path and one is reserve. So what happens? So in a flow, what happens? The receiver is making reservation, right? So this suppose this S1 is the source, this is the source, and these are the receivers, right? So what will happen? This source will send a path message to all the receivers. Okay. So this path message travels from the sender and reaches all the receivers in the multicast path. On the way, a path message stores the necessary information for the receiver. So whenever this path diverges, it goes in this direction and this direction also. So here a new message is created and it's sent in a different direction. We can say that it is diverging, going in a different direction. So here new packets are created, no problem, right? So that it could reach all the receivers. Now we have to say something. What happens after this path message has been received, right? So then after a receiver has received a path message, it sends a RESV, reserve message, right? So the reserve message, RESV message, travels towards the sender and makes a resource reservation on the routers that support this protocol RSVP. If the router does not support this RSVP on the path, it routes the packet based on the best effort delivery methods. Otherwise, if it supports RSVP, it will reserve the resources. So this is how this RSVP protocol works. Very simple. However, if you think this happened, and what about the quality of service, maybe requirement of bandwidth? So this reservation can be merged. See, basically what happens in RSVP, the resources are not reserved for each receiver in a flow, right? The reservation is merged. So in this figure, as you can see, this receiver 3 is there, right? It requests 2 Mbps bandwidth, while this RC2 requests 1 Mbps, right? Router 3 actually it needs to make a bandwidth reservation, merges the two requests, 2 and 1. The reservation is made for 2 Mbps, the larger of the two, because 2 Mbps input reservation can handle both the requests. Okay. The same situation is for this R2 also. From here we are getting 2 Mbps, and here the request is of 3 Mbps, so we can understand that it will be reserved for 3 Mbps, right? And here it is 3 Mbps. So in this way these requirements are merged. So I should say the reservations are merged. Okay. So this is something about resource reservation. However, you can think of some reservation styles. There are certain reservation styles when there is more than one flow. The routers need to make a reservation to accommodate all of them, right? So RSVP actually defines 3 types of reservation styles. They are this thing: wildcard, fixed filter, and shared explicit. In this wildcard filter style, what happens? The router creates a single reservation for all the sender. It has single reservation. So the reservation is based on suppose largest request, right? This type of a style is used when the flows from different senders do not occur at the same time. Fixed filter. What happens in this style? The router creates a distinct reservation for each flow. Distinct reservation for each flow. Okay. Now this type of a style can be used when there is a high probability that flows from different senders will occur at same time. Shared explicit is a style the router creates a single reservation on that can be shared with the set of flows. That is the thing. Okay. Now let me tell you about the problems related to this integrated service. Actually, these two problems can be named. One is scalability and another is service type limitations. So actually the integrated service model requires that each router keep information for each flows, you know. So as the internet is growing every day, this is a serious problem for integrated services. Like the routers will have to keep information of all the flows, each flow, right? That is the thing. Now this is service type limitation means the integrated services. Here we are using integrated service model. It provides only two types of services: guaranteed and control load. So those opposing this model, they say that the application may need more than these two types, right? There can be several other types of services that may be needed. So we are going for differentiated service. What happens in differentiated service? Actually, okay, we are saying that it was designed by IETF. No problem. It was designed for handling the shortcomings of this integrated service. Basically, the two fundamental challenges that we have seen, one was scalability and type service. So here what happens, the main processing actually earlier in integrated service was being done on routers, right? So now the main processing was moved from the core of the network to the edge of the network. So this solves the scalability problem. The routers do not have to store information about flows, right? Now the applications or hosts define the type of service they need each time they send a packet. And the second thing was service type limitation. So the per flow service is changed to per class service. So the router routes the packet based on the class of service defined by the packet, not the flow. This solves the service type limitation problem. So you can define different types of classes based on the need of application. Okay. So in this way, a differentiated service works. So actually, differentiated service is a class-based quality of service model, not flow-based. The integrated service, as we see, it was flow-based. Now it is class-based, designed on IP only. Now we are going to say what is the DS field actually. Here in this differentiated service, each packet contains a field which is called DS field. So the value of this field is set at the boundary of the network, right, on the edge by the host or the first router designated at as the boundary router. So what this IETF people have proposed is to replace the existing type of service field in the IP version 4 or the class field in IP version 6 by this DS field. So actually this DS field contains two subfields. This thing is DSCP and CU. DSCP is actually differentiated services code point. Differentiated services code point. Okay, it is actually, you can see, you cannot see, it is 6-bit. And this subfield defines the per hop behavior. Okay, how it will behave per hop. What will for each node it will tell you about the behavior. Okay, let me tell you about per hop behavior. Actually, this differentiated service model defines this per hop behavior for each node which receives a packet. So for now we have three different per hop behavior defined till now, right? One is DE, one is EF, and the third is AF. Okay, so in DE what happens, it is default actually. So it is same as best effort, right? Means it is similar to the type of service that we have filled in IP. If you think about EF, what actually happens, you can think it as expedited. Okay, so it actually, what it does, it provides you with let me change the color. So it provides you low loss, low latency, as well as ensured bandwidth. Okay, so this will ensure you have a virtual connection between this thing, source and destination. If you think about AF, what will happen in AF? Actually, you should say it is assured. So what happens here? It delivers the packet with a high assurance, as long as the class traffic does not exceed the traffic profile of the node. Now, in the next slide, we have a traffic conditioner. Okay, so suppose if you want to implement this differentiator service, the DS node actually uses traffic conditioners such as meters, marker, shaper, these information, right? Basically, meter the meter checks to see if the incoming flow matches the negotiated traffic profile. This much requirement, this much bandwidth, and it also sends this result to other components, the meter as well as the shaper. It can use means whatever needed, token buffer, token bucket, or whatever to check the profile. This is marker. This marker can remark a packet that is using best effort delivery, or downmark a packet based on information received from the meter. Downmarking means lowering the class of the flow. It occurs if the flow does not match the profile, right? The marker does not up mark a packet. It cannot promote the class. It can only demote the class. Now this is shaper. What it does, it uses the information received from the meter and reshapes the traffic if it is not compliant with the negotiated profile. You also have a dropper. What this dropper does, it works actually as a shaper only, but it does not have a buffer. It just discards the packet if the flow severely violates the negotiated profile. This is how this traffic conditioner works and how these differentiated services are implemented. Okay. So now we have seen this integrated service and differentiated service. Along with that, we have seen RSVP protocol. Thank you.